Operating with fractions is what most textbooks focus on. But in order to understand the actual operations, we first need to develop fraction sense. So we need to build our number sense around fractions, and we need to build our students' fraction sense as well. Schools don't spend enough time helping kids build fraction sense. It's the textbooks. Textbooks will jump straight into here's what a fraction is, and then here's the steps to operate with them. Kids don't get time to develop their fraction sense. What I want to dig in with you today is how to build fraction sense in the elementary grades. Even if you teach the younger grades, I'm going to encourage you to still watch this, because if you're like me, you never got to build your fraction sense, right? You just had to operate with them, and you were basically memorizing those steps and have no sense of fractions. I know it was a huge game changer for me when I learned and developed my fraction sense as an adult. And it helped me finally make sense of a lot of the fraction stuff I was doing. I do have full online courses about building number sense. The flexibility formula is what it's called, and we do a deep dive into each of the concepts I'm going to talk to you about today. There's a course that's for K2 and there's one that's for 3-5. And just so you know, the 3-5 one, we look at how number sense does impact fractions, but we also look at how it impacts multiplication, division, and multi-digit addition and subtraction. So if you want more help with building your students' number sense, which is what I call their math flexibility, I'll post a link to enroll in the courses below this video. All right, let's dive in to the 8 number sense concepts that help build fraction sense. We're going to break up the 8 number sense concepts into the 4 early numeracy concepts and then the 4 number relationships. I'm going to go through these fairly quickly, and we are only looking at them through the lens of fractions. There is so much more to building number sense around all numbers, but we're just looking at fractions. So the 4 early numeracy concepts are subitizing, verbal counting, object counting, and cardinality. First off, subitizing. If you've taught the early grades, you know about subitizing. We spend a lot of time talking about subitizing with whole numbers and with small amounts. And so if you're not familiar with subitizing, watch your screen. Subitizing is the ability to instantly recognize. So I'm going to flash an amount up on the screen and see if you can tell how many that is. Ready? Here it comes. Could you tell how much that was? Right? If you were able to, you were able to subitize that amount. And we do a lot around this in the early grades, as I said, but the more I've worked with kids of all ages, I really love focusing on subitizing, even with fractional amounts. Okay, so come back, watch your screen again, make sure you've got the screen on here, because I'm going to show you what this looks like with a fractional amount. Ready? Here it comes. Could you tell what fraction was shaded? And I'm also curious, could you tell me what fraction was not shaded? Right? And I know that's fast, but it's to kind of show a point here that subitizing is that ability that you can see something quickly without needing to count. Your eyes recognized how much was there, and you put it together in a fractional amount that 1/4 was shaded and then 3/4 was not shaded. Now, I'm not saying we need to do this for all kinds of fractions, right? This is a document that people inside of the 3rd through 5th grade flexibility formula course get, that we put together a lot of visual images, and then they can change out and color, uncolor things to make their own subitizing cards for fractions. And I'm not saying you need to make subitizing cards for things like up to 16ths. We use them for other things beyond just subitizing. We should be able to subitize the common fractional amounts, things dealing with halves, fourths, thirds, maybe even fifths, right? Our ability to recognize and be able to subitize, even as adults, ends around 5. So I probably wouldn't go higher than fifths unless it's something like a common arrangement that they see very often, okay? You can make these easily on your own. It's just a bunch of shapes, and then I colored them in or not color them in. But I do want to caution you, I really want to encourage you to only use 2 types of images for subitizing to at least begin with. Number 1 is the tape diagram, and it's just the rectangle right here where all of the partitions are vertical. This is known as a tape diagram. When you have some vertical and horizontal, it's the area model. So these 2 are my preference. I don't like to start out with circles. I think it's harder for kids to see. I'm not saying you can't do it. I'm just saying I would start here. And I also would not do parts of a set where you have like 4 separate things and then one of them shaded in, right? We want to keep it contained. We want it to be part of a whole. So it needs to be something like this. These are the 2 that are the most recommended for beginning work with fractions. So that's where I would recommend that you start creating your own. The next one is verbal counting. Oh, and I forgot to mention, all these 4 early numeracy concepts come from the work of Clements and Sarama. Now, they call verbal counting, they have a different word for it. It's much more academic sounding, and I just like verbal counting because it helps me remember exactly what the kids are able to do. Verbal counting is just the ability to count in order. We spend a lot of time in the early grades getting kids to do this with whole numbers, but how often do we count with fractions? How many times have you asked your students, start at 8/3 and count by 2/3? Right? It's becoming more and more popular, and this is why. Counting is foundational to building a sense of numbers. If we can't count, it's really hard to operate with them, right? Addition and subtraction is based on counting. That's how kids first learn to add and subtract. So it should be how they first learn to add and subtract with fractions as well. We need to be able to count with fractions. Now, this is a little bit more advanced, starting at 8/3 and counting by 2/3, but just start at 0. Start at 0 and count by 2/3. Are we able to do that? A lot of us struggle with this to begin with, but it's just like counting. It's 0/3, 2/3, 4/3, 6/3, 8/3, and so on. We want them to see how counting with fractions is really similar to counting with whole numbers. Now, just being able to count is not the full picture, right? Just like when kids start out, it's not just we want them to say the list of number names in order. We need them to actually attach those counts to something. Just because they can say 0, 1, 2, 3, 4, 5, 6 doesn't mean they actually understand counting. They need to attach those counts to something. And then what's known as cardinality is that once they're done counting, they understand the last word that they say says how many. So if they count 5 things and then you say, so how many is there? Can they tell you 5? Or do they just go right back and count again? What this looks like with fractions. A word of caution when we're getting kids to count objects, okay? Object counting with fractions. Kids want to count the stuff. And so we teach them this also, like just count how many are shaded. So they get the 1. And then we say, how many total parts are there? And they count the 4. And then we just tell them to put a symbol, a slash between them. And that's fine. That's a place to start. But it leads into kids, when they see an image like this, they take that and they say, well, there's 2 shaded and there's 3 total parts. So it's 2/3. This understanding of seeing how many parts are shaded and how many total parts there are is a foundational piece of fractions, but it's limiting kids. It's known as partitioning, where we have the whole and we cut it into the parts and we're looking at the parts individually. How many parts are shaded? How many parts are there total? And another view of fractions is what's known as iteration. Iteration is the understanding that what I call that shaded part depends upon what the whole is, and it is called that based upon how many iterations it takes to create the whole. So I have to take that piece and I iterate it as many times as it takes to make the whole, to fill the whole up. And this one took 4. It took 4 iterations. I had to repeat it 4 times. It's 1/4 because it takes 4 iterations of it to fill the whole. That's a different view of fractions, but it is a big, big piece that we need to get kids to understand. And this is something that helps with the object counting, getting kids to see the repetitions of that piece of the unit over and over is basically the object counting of fractions. So if I want to determine the value or size of that yellow piece, it is dependent upon what the whole is, what 1 is worth. So if I say this green piece is 1, it's the whole, what's the yellow, right? To be able to figure that out, I have to iterate it until I can see how many iterations it takes to fill the whole. And once I'm at that point, I can see it's going to take 3. So one of those, the original yellow, is 1/3. That yellow piece is considered 1/3. But it's only 1/3 if that green is the whole. That's one of the cool parts of fractions, but also a hard part of fractions. The value is dependent upon the size of the whole. And if the whole changes, or what's considered 1 changes, the value changes. So if I now use this gray one and I say the gray one is worth 1, now what's the yellow worth? The yellow is no longer worth 1/3. And in order to figure out what the yellow is, I have to iterate it over and over to figure out its value. And that's like the object counting. You're counting to figure out, you're iterating the piece over and over to figure out its value. And then once you've figured that out, cardinality is knowing the amount once you've done the counting. That's the cardinality piece, okay? So that was the 4 early numeracy concepts. And again, we're just skimming the surface on this because I don't want this to be like a 3-hour long thing for you. Up next are the 4 number relationships. These come from the work of Van de Waal and friends, and it actually comes from their book that is for pre-K to 2nd grade. But again, once I learned these things and I started working with kids of all ages, I realized kids of all ages need these 4 things around all kinds of numbers that they're working with. So we're going to, again, take a look at these 4, but through the lens of fractions. Okay, so first one is spatial relationships. Spatial relationships is having a visual of amounts, but being able to look at how it relates to other amounts. So if I just have this image and I ask the kids, how much is shaded? It's building an understanding of 1/2 and what 1/2 looks like, but we aren't building any relationships to any other fractional amounts. Building the spatial relationship is about then attaching another quantity to it and talking about the relationship. What do you notice is the same? What do you notice that's different? How does 1/2 relate to 1/3? You have to have these visuals for kids, because if I just put up the number, the fraction 1/2 and the fraction 1/3, and I ask kids to talk about how they relate to each other, how they compare, it doesn't build much sense around those fractional amounts. So we need the visuals. That's the spatial part to help build relationships around quantities. The next relationship is 1 or 2 more or less. We spend a lot of time doing this with whole numbers. What's 1 more? What's 1 less? What's 2 more? What's 2 less? What's 10 more? 10 less? Kids need this around fractions as well. If we have this image of 2/4, we can ask questions like, what's 1/4 more? What's 1/4 less? What's 2/4 more? What's 2/4 less? And yes, you can even ask, what's 1 whole more? What if I added 1 to this amount? How much would I have? But we want kids to be able to instantly tell us what's 1 more of whatever unit fraction we're working in. If the picture had shown thirds, I would ask, what's 1/3 more? And again, having these visual pictures helps beyond measure. Like it is such a big difference when you attach visuals or manipulatives instead of just the fractions, like the digits on a paper. This helps kids, this idea of 1 and 2 more or less. Counting is the foundation of addition and subtraction. This understanding of 1 and 2 more or less is the first thing where we're adding 1 and 2 more or less. With fractions, it is so hard for kids to understand that this problem is not equal to 9/16. 7/8 plus 2/8 does not equal 9/16. And you can tell them till you're blue in the face that you only add the numerators, the denominator stays the same. But if they don't have a sense of fractions, if they haven't counted with fractions before, if they haven't had the experiences around 1 and 2 more or less, they still think they need to add those denominators, and they will do it every time. We need to build their sense of fractions, and when we do that, they understand that the size of the pieces does not change, just the amount of those pieces changes when we add and subtract and when we count, right? All of these number sense concepts work together. Another number sense relationship we need to build is the benchmarks. In the early years, it's like the benchmarks of 5 and 10 and 50 and 100. But when it comes to fractions, we need to build their relationships to half and a whole. So 1/2, 1, 1.5, 2, 2.5, 3, right? All of those, but also the equivalents of those, that it's not just 1/2 and 1, it's 1/2 and it could be 2 halves, then 3 halves, then 4 halves. And with any denominator, right? We want them to be able to see that it is 3/6 and 6/6, or it could be 10/20ths and 20/20ths. We need them to understand those equivalences and how numbers relate to those halves and wholes. It's not just to have them memorize and understand equivalence. It helps kids with comparing fractions as they move forward, but also with addition and subtraction. When kids understand how fractions relate to those benchmark numbers, when they start adding and subtracting, they're going to use that fraction sense to make problems friendlier. We talk so much in the early grades about make problems friendly, like make it 10, make it friendly. Well, when it comes to fractions, make it a whole number. Could I make one of these numbers a whole number to make the addition easier? And kids will naturally do that if they've built their fraction sense. Kids naturally see that 2 3/4 is darn close to 3, and they'll want to round it to a 3, or they'll want to add some, right? They do all kinds of different strategies. This is just one example of what we've heard kids say who have built a sense of fractions when they go to add and subtract fractions. Part, whole. Now, a lot of people are talking lately that we should not call it part, whole, but we should call it part, total. And I have not changed it because this comes directly from Van de Waal. These are not my words. They talk about it as part, whole. So I leave it as part, whole. And that's a discussion for another time. But part, whole is all those activities in the young grades where we have kids take a whole and we break it apart into all the different parts that you can make, right? Like we ask kids to decompose 5. What are all the ways that you can make 5? And so they come up with 4 + 1, 3 + 2, 5 + 0 plus the others. And we could break it down even more than that, right? We could even have 1 + 1 + 1 + 1 and have 5 ones there. So it's similar to that, but now we're doing it with fractions. Can you decompose or break 5/8 up into different parts? What kind of parts can you get if you have 5/8? It's the same as decomposing 5. We still have 5 things. We have 5 1/8 pieces. I can have 4 1/8 pieces and 1 extra one. 4 pieces and 1 pieces makes 5 pieces. The size is just that they're an eighth. I can have 3/8 plus 2/8. I can have 5/8 plus 0/8. Whatever way I decompose 5, I can decompose 5/8 in that same way. I can have 1/8 plus 1/8 plus 1/8 plus 1/8. You get in the picture, right? You can decompose 5/8 in all the same ways. Now, why is this important? Again, it's not just to do it just to make them do it. It's because it builds such a sense of what these fractions actually are. And then they can use that understanding again when they go to add and subtract and multiply and divide. If they understand that 5/8 can be 4/8 plus an eighth, that it could be 3/8 plus 2/8, that it could be 5/8 plus 0/8, could they use one of those things to help them make this problem friendlier? Could they use one of those things to make one of the benchmark numbers, right? Turn one of those fractions into a whole number to make it nicer, or to find halves out of those, right? There's lots of different ways that kids will make this friendlier. Here is just one example. We've seen kids say, well, 2/8 is the same thing as a fourth, and I need a fourth to make that 2 3/4 a whole. So they'll pull the 2/8 out, and then they know what's left over. And then the problem becomes 3 plus 3 3/8. That's a whole lot easier than doing 2 3/4 plus 3 5/8, right? But they have to have a sense of fractions to be able to do that. So those 8 number sense concepts are a huge, huge piece of it. And remember, this is just an overview of those 8 number sense concepts. Inside the flexibility formula, we do go deeper into those. We talk about how to assess students, how they help kids understand the operations, which you got a little bit of that in this video. And then I talk about experiences. I like to call them experiences, not activities, because we want kids to experience mathematics, not just have a lesson or an activity that we put them in. So we talk about experiences that you can provide your students to help them build these number sense concepts around, like I said, fractions, multiplication, division, and multi-digit addition and subtraction. I talk a lot in other arenas about how you cannot directly teach these number sense concepts to kids. Even young kids, like you can't just say 4 is 1 less than 5, learn it, know it, memorize it. These number sense concepts kids need to play around with. They have to dig into it to build their number sense. And I say it all the time, number sense can't be taught, it's caught. They catch it by playing with numbers. And that holds true even when kids are trying to build their fraction sense. Their fraction sense can't be taught. It's caught. I hope, as always, that this video has helped you build your math mind so you can go build the math minds of your students.